Okay, if we have more than one line in 2D and in 3D, then they can fall into one of three categories. So the lines can be totally parallel. They run in the same direction, but they never intersect. They can intersect. They can be the same line. And then in 3D, we can add one more category. We can add a skew line where the lines are not parallel and they will also not intersect. So in order to find the point of intersection of two lines, we used linear systems. So substitution or elimination. So we'll just quickly remind you how to do that. So first let's do substitution. So I label my lines 1 and 2. I set them both equal to each other, set them both equal to y. So I have 3x minus 5 equals negative 2x plus 10. I'm going to rearrange and solve for x, and I find that x is 3. I take this answer and I plug it into 1 or 2. It doesn't matter. Even both is better so that I can verify my answer. So that was it in 1. Let's double check it in 2. Negative 2 times 3 plus 10. Oh, shoot. And it's a good thing here because I wrote that totally wrong. Negative 6 plus 10 is 4. Therefore, my point of intersection is happening when x is 3 and y is 4. The other strategy that I had to solve these equations was to use elimination. And in order to do that, I would be pretty well similar, but I'm going to, again, label these lines 1 and 2. And then I'm going to do something, manipulate one of these lines in some way so that when I add them or subtract them together, they will become 0. So what I'm going to do is let's take 2 times line 2 and add that to 0, or add that to line 1. Okay. So 4x plus 2 times 2x is 4x, so that'd be 8x. Negative 2 plus 2 times 1 is 0. 3 plus 2 times negative 4. 2 times negative 4 is negative 8. So this is 5. X equals, negative 5. Negative 5 over 8. Now that I have that, I can sub that into one of my two lines, doesn't matter which. So I have 4 times negative 5 over 8 plus 2y equals 3. This is going to become negative 5 over 2 plus 2y equals 3. Three plus 5 over 2 is 2y. 3 halves is 6. This is 11 over 2 divided by 2 is 11 over 4. Oops. Okay, so my point of intersection here is negative 5 over 8 and 11 over 4. Okay, let's look at the parametric form and use that to help us find the point of intersection. All right, so first up, my parametric equations. I'm going to talk about what does x do. Well, x is starting at 2 and it's going 3 each time. And in line 2, x is starting at 1 and it's going 2 each s time. And I'm going to compare that to what's happening in y. So y is starting at -3, and it's going down 1t every time. And I want to know when that is equal to when I'm starting at 5 and I'm going up 1s each time. So these are the two systems that I'm going to use. I can label them 1 and 2. And I'm going to manipulate these to figure out where their point of intersection is. So in this one, I'm going to go 1 minus 2 times 2. 2 minus -3 times 2 is 8. 3 minus 2 times -1 is 5. 1 minus 5 times 2 is 10, so that's -9. And 2 minus 1 times 2 is 0. Okay, so I eliminated the s, and now I'm going to rearrange to show that 5t equals -17 and t equals -17 over 5. Okay, now that I have that, I need to find out the s value. So I'm going to solve for s. So I'm going to put that into an equation for s. So I have -3 minus t, no, sorry, I don't, is equal to 5 plus s. I just found that so that t is -17 over 5. Okay, -3, well, let's take away 5 first, is -8, and -8 take away -17 over 5. I'm just going to do that on my calculator. I'm going to get 23 over 5 is s. Okay, so now I know how many steps each line needs to go. And so now I need to actually figure out this point of intersection. Okay, so the line 1, it's happening when t equals -17 over 5. Okay, so x starting at 2 plus 3 moving -17 over 5. I'm going to put that in my calculator. I get -41 over 5. And the y starts at -3 and just moves once, -17 over 5. Put that in my calculator and I get 2 over 5. So line 1 is hitting this point, -41 over 5, 2 over 5. And then I'm going to check line 2 when s is -23 over 5. So x in line 2 starts at 1 and goes to -23 over 5. And 1 plus -23 over 5 is -41 over 5, so that looks good. And then y starts at 5 and moves -23 over 5, and 5 take away -23 over 5 is 2 over 5. So my point of intersection is -41 over 5, 2 over 5. Okay, let's try another example. So I have these two vectors here. I've got R1 and R2, and I want to know where they intersect. So the first thing that I'm going to do is I'm going to write my parametric equations for these two vectors. And so in x, I'm starting at -1. y is going to start at 3, and z is going to start at 6. In line 1, x is going to move 1 each time. Y is going to move 4 each time. And z is going to move 5 each time. And that's what's happening in line 1. In line 2, I'm starting at 4, 17, and 30. And x in line 2 is moving negative s each time. Y is moving positive 2s each time. And z is moving negative 5s each time. Okay, I'm going to label these 1, 2, and 3. And I need to eliminate a variable here. So I'm going to do 2 times 1 plus 2. All right, 2 times 1 is negative 2 plus 3. That's negative 1. 2 times 1 is 2 plus 4 is 6. 2 times 1 is 8 plus 17 is 25. And 2 times 1 is negative 2 plus 2 is 0. So 60 equals 25. Oh, sorry, this is a plus 1. Take away 1 is 24. T equals 4. Okay, now that I have that, I'm going to take this information and I'm going to sub this into a line. Doesn't matter which line. Okay, you'll sub it into line 1 because line 1 is simple. So negative 1 minus 4, sorry, plus 4 equals 4 minus s. Well, this is telling me that s equals negative 1 equals negative s, so s must equal 1. Okay, now I know the value of s and t when this is happening, so I'm going to sub that into line 1 to figure out the point of intersection, and then line 2. So line 1 at t equals 4. So negative 1 plus 4. 3 plus 4 times 4. 6 plus 4 times 5. My x-coordinate is 3, my y-coordinate is 19, and my z-coordinate is 26. Just going to double check with line 2. When line 2 has moved negative 1, x, y, and z, 4 minus negative 1, oh sorry, not negative 1, positive 1, 4 minus 1, 17 plus 2 times 1, and 30 minus 5 times 1. 4 minus 1 is 3. 17 plus 2 is 19. And 30 minus 5 is 25. Oh, well, this is saying that the point of intersection is 3, 19, 26. This is saying the point of intersection is 3, 19, 25. These lines do not actually intersect. They are skew lines.